This is Mike Azar. I'll start us off today. And I just want to start by thanking the ERP team that supported us for this implementation and the Sparx development and engineering teams. Without them, we couldn't have gotten as far as we have. In our agenda today, we're going to look at some of our drivers for CMS's EA business needs, look at how we implemented Sparx Collaborate and our timeline, installation of the tools in our cloud environment, as well as the API integration approach, followed by a live demonstration, fingers crossed, and then we will wrap it up with a little retrospective. I wanted to give a little bit of a background of what CMS was for those that may not be familiar. CMS is the Centers for Medicare and Medicaid Services. It's a federal agency in the U.S. Department of Health and Human Services, and we are responsible for administrating the Medicare program for adults 65 and older. That includes around 65 million covered lives at a cost of $900 billion US, and the Medicaid program, which works in partnership with U.S. state governments to administer Medicaid and the Children's Health Insurance Program, which covers over 94 million lives at a cost of $734 billion US. And finally, the health insurance marketplace that acts as a one-stop shop for affordable healthcare insurance coverage. So as you can see, we're responsible for paying a large swath of the healthcare for the U.S. population. So given the mission that we in EA look to leverage, given that mission, we in EA look to leverage several strategic use cases to make the best use of our tight resources. At CMS, we have a decentralized enterprise architecture program, which means the EA function is spread across several divisions within our organization. So when looking at EA within CMS, it is heavily business focused and matrix to the budget and technology aspects of the program. In working across this function, we wanted to come up with some specific use cases that could drive our architecture. So we started with these 6 that you see here. Assess health legislation impacts to the CMS business and IT operations. Our knowledge of previous legislation and how that legislation maps to systems drives one of our strategic use cases. Then we have something called the system census that I'll talk about a little bit later to enable real-time IT asset management. We have our business architecture services that we offer to anyone in the organization, big or small, as well. And as I said before, we help facilitate the capital planning and investment control through our analysis, and we support the governance boards for decision making. Finally listed here is one of our initial uses of enterprise architecture, which is a requirement to provide reports to the Department of Health and Human Services. So that gave you a strategic view of how we see our enterprise architecture program delivering value. However, to do any of those things, we need the data. And the data comes from our partners, and we gather that data in 3 different ways. First is project engagements. We engage our partners through specific projects. They come through our governance process because they either want to purchase a new piece of technology or they want to upgrade their current IT system. We work with them to document the business before we start talking about any technology. We've documented and maintained over 2,400 business processes and other artifacts over the last 15 years with several different tools that we won't talk about, but we have a history of using various tools within this space. We don't just document for document's sake. We try to deliver value. So we begin each of our engagements with our partners first by understanding and documenting their business needs and concerns. We use what we collect either through a business process model, high-level concept graph, or other artifacts to collect data around the business of the organization. The other ways we get information into our e-repository is by conducting an annual system census of all our IT systems. And the third is by creating integrations between other source systems. So by collecting this data, both from a modeling perspective and from the system census and our integrations, we create visualizations for our partners and our own analysis. We conducted a design sprints with our partners to develop dashboards to do real-time or near real-time views into our IT environment. And one of the reasons we made the move to Sparx EA is because we needed that data-centric capability versus a model-centered approach, since more than half of our data that we collect did not come from a model. So when we used a model-driven tool, it caused a lot of extra work behind the scenes to enter and maintain that information. Another must-have for us was the use of the out-of-box functionality versus customization. We found that customization caused a lot of rework and extra work every time we had to upgrade to the next version of software, leaving us in a continual mode of planning for upgrades rather than working on data visualizations and our partners' requirements. So for those that like pictures, you can see our picture here. It's a logical view of how we see our EA repository, which we call CEDAR, the CMS Enterprise Data Analytics Repository. This represents our logical cloud CEDAR environment, and we include things such as Collaborate, ProCloud Server, and our API toolset, and our system census and web application there at the bottom. So we connect through our API toolset. We pull data from Flexera's Technopedia, our system security application, and our governance intake system, along with the Sparx EA tool. The data coming from these inputs are leveraged to create dashboards using Collaborate for capital planning and governance teams, which you'll see a demonstration of shortly. So essentially, the center is the core of our CEDAR system, and the left side are inputs, and the right side is the output. And I'm going to turn it over to Crystal to walk us through the rest of our journey.
Good afternoon. As Michael said, my name is Crystal Russ. I'm the ERP's lead enterprise architect for the program. In June of 2021, CMS decided to address the challenges of the current EA tool suite architecture methodology by embarking on the EA tool migration. ERP's tool migration approach consists of 4 major phases. Phase 1, conduct the EA assessment. Phase 2, document EA and tool requirements. Phase 3, conducting the tool assessment itself. And finally, implementing the new tool and methodology. In Phase 1, the green area on the slide, Team ERP began to investigate all the relevant architecture documentation, architecture repositories, and stakeholder requirements to determine how the architecture was developed and how the relevant components met the needs of CMS. Not only did it tell us where we are, but where we needed to go. In Phase 2, the dark green area on the slide, we began having design sprints, as Mike had mentioned, to discuss current and future architecture methodologies, visualization, reporting requirements, and tool capabilities. This gave an opportunity for our government and contractor team to level set our EA knowledge, identify opportunities for additional training and mentoring along the way. Because the design sprint attendees responded well to visual representation of the requirements, we utilized a visual collaboration tool to visually represent the EA tool requirements, as well as conducting prototyping sessions to ensure requirements were captured correctly. During Phase 3, the dark blue and turquoise area on the slide, our team began to document all the requirements that would be used in the vendor assessment. We leveraged ERP's proven tools, templates, scripts, and formulas to complete the tool assessment products. A demonstration script was also created to provide each vendor to ensure that they demonstrated consistently across the vendors. A key takeaway from this process was that vendors don't always follow instructions, unfortunately, and we need a way to validate everything that is provided by the vendor. David Rice, our senior engineer, who has a vast amount of experience in the EA tool industry, validated some of the key critical components of the assessment and was able to challenge some of the vendors' results. And finally, Phase 4, the orange and red areas on the slide, Team ERP finalized the results of the tool assessment and proposed a recommendation to the government. I will talk a little bit more in detail about the tool assessment approach in the following slide. After the recommendation was accepted by the government, our team immediately obtained the licenses to begin work on the initial operating capability of standing up the Sparx platform in the CMS cloud environment and delivering the initial architecture modeling capability. On September 13th, we began working with Sparx Systems of North America to establish a cloud environment to pilot the tool capabilities and to begin pre-configuration of the tool. This allowed us to continue with our tool configuration while getting the CMS cloud environment ready for the Sparx platform. After CMS cloud environment was established, our configured pilot instance was migrated over to the cloud environment, and the initial modeling capability was delivered. This was completed in 3 months. The next operating capability to be delivered was to continue with the tool configuration and to develop collaborate dashboards, complete the data migration from the legacy systems to the Sparx platform, and the implementation of 100+ APIs, all by May 15th of 2023. This was delivered on time and on budget. Shahram, our senior cloud engineer, and Don, our senior API developer, will be speaking more specifically to the cloud and API challenges and solutions during our implementation. In our next slide, ERP's tool assessment approach for CMS consisted of 4 assessment products. Product number 1, the vendor and tool assessment, self-assessment. This is an example of the vendor's assessment template that was created for the CMS project. As you can see, not only were we documenting the requirements, but we also provided visualization examples that the customer was looking for as part of the tool's visualization capabilities. Each of the requirements was reviewed, asserted to by the vendor. Each vendor was given a weighted score for each requirement, and an overall score was calculated based on their final assessment results. Those results could be then compared side by side with all the vendors to determine the highest score. Product number 2, license and infrastructure cost analysis. There are 4 different cost areas that were considered when getting pricing information from the vendors: the license types and costs, the infrastructure costs, which includes servers, cloud storage, and security requirements to deploy the Sparx platform in your environment, training costs, which I highly recommend you include in your pricing model, and finally, the Sparx Systems support and maintenance costs. Because we had very experienced tool experts already on the program, we were able to provide training support and maintenance of the Sparx platform in-house. However, we did decide to purchase the additional Sparx Systems technical support to maximize the tool's capabilities. Product number 3, demonstration scripts and vendor demo. This product was created to specifically address the demonstration of the tools across the vendors and to ensure we were able to compare apples to apples in functionality, capability, visualization, reporting, and ease of use. Questionnaires were created for the attendees so we could rate the tool's capabilities and submit them as part of the final tool assessment. And finally, product number 4, the consolidated assessment. This is an example of the consolidated assessment provided to the client that shows the overall score from the assessment, the rating based on demonstration results and viewer feedback, and finally, the cost analysis. As you can see, we did not provide the actual vendor names to protect the possible sensitive information. However, Sparx Systems was the top-rated software in all 3 categories: highest score on self-assessment, rated high based on the customer reviews, and finally, the pricing was the most cost advantageous for the government. To note, we did assess 4 products and 1 vendor was non-responsive to our assessment, so they were eventually removed from the final assessment. Now I'd like to hand it over to Shahram, our senior cloud engineer, to discuss the AWS.
Good afternoon, everyone, or good evening, based on where you are. My name is Shahram Ghaffari, senior cloud engineer on this program. This slide that you are seeing on your screen is actually a spec of our AWS footprint for CMS. We are sub-organization. This account is AWS account, is a sub-organization we all familiar with on an AWS CMS AWS cloud presently. And we are inheriting some of those services as part of the CMS cloud that provide to our account. I'm going through this slide because I want to give you, everyone, the understanding of how we implemented the environment on AWS Cloud, what services and what tools been implemented across, and in what topology it's been implemented. This is according to not latest NIST template. We are migrating to the latest NIST to separate the workload of the dev and production on the two different AWS account, but this is implemented currently and we are in migration process. As I mentioned, and my colleagues Mike and Crystal mentioned, we are providing some services, receiving and providing data back to some of our customers, internal agencies or external agencies, and that would be through the AWS Transit Gateway or peering connection through AWS VPC services. Our AWS account is divided in three VPCs. Each VPC has 5 subnets. Each VPC is enclosed on for dev, test for Intel environment, and production environment. So the graphic that you are presented are for one VPCs, and that would be on production VPC. We are divided each VPCs into 5 subnets, and that's standard across all CMS accounts at the time. And we had DMZ subnet, web subnet, app subnet, data subnet, as well as management subnet. As you can see, data subnet is way behind all the public or any access to outside of our account. It's isolated through app subnet and web subnet, as well as DMZ subnet. All the traffic are passed through NLBs, network load balancer, and in follow goes through some aspect of the session or cookies management for our business requirement, and then they pass through our ALBs, application load balancer, and is spread out across different subnets, as you can see in our graphic. We are not required to deploy any second availability zone. These are only on one availability zone. We did deploy communication mechanism across other availability zones, but the deployment was only on one availability zone. There are the couple of areas that I want to mention. We were as part of the demonstration of by the vendor was providing all SSO single sign-on as a capability that they can support, and we reached out. CMS was providing the SSO through SAML token, and we implement those, and I go through those later on. There are some of other services that we were receiving as part of the CMS organizations, like patching, security, DNS, name resolutions, and routing, firewalls, and so on. Those are the standard enterprise services that CMS provide across all the organizations, sub-organization, and sub-account through the AWS, through all the AWS accounts. Next slide, please. I just want, and then David. Thank you. I just want to go through planning phase, what phase we go through our deployment of the Spark after being chosen. We go through the design process. We have a collaborative working session with Sparx team, how we're going to design it, evaluate our workload, our footprint, our user base, and based on those, we had a couple of main categories to decide our implementation strategy. We did discuss those into the detail on all those criteria with the Sparx team to understand and make sure those are supported both on in respect to Sparx team platform as well as system and Windows OS or databases. Then we scheduled a working session with the Sparx team to provide support and walk through how we're going to install their platform or and the systems across AWS subnets. We provide how we're going to implement those across each of our subnets, where each component of their system will reside on our AWS account. Then we deployed our development environment. We went through the phases of the tuning our development environment based on requirement, capabilities, and users' expectation. We were expecting to have on development environment for 25 ProLaborate user and 20 Sparx EA feature-rich client application. On our test or Impel environment, we had 25 same license as well as 25 ProLaborate and 25 Sparx EA. But in production, we had 100 ProLaborate license. We were expecting 100 simultaneous user. These are assigned user. Sparx license model is assigned user. So as soon as you add the user into the access group, the license would be subtracted from available license. As well as same goes for a Sparx EA feature-rich client. We provide zero installation clients for federal government provided laptops, so they can easily extract the zip file and install on their platform or on their laptop. We solved all these installation on a dev, Impel, and Prod. We did it with receiving Sparx support without having a license agreement in place, and that's what I'm going to recognize Sparx collaboration for our installation. We went through the security finding. We scanned the system. The design that we were provided for the scan find 8 findings, and we collaborate with Sparx team to resolve these findings. 6 of them resolved within 30 days, and that was very critical for our security team to resolve this. If we can resolve this within 30 days, they will not require MOU or memorandum of understanding. And that's, you all know, different process. 2 remain out of the 8, and that resolved in the next 2 release of the Sparx deployment. We did resolve all 8 of them, and we scanned the system. We provide the system to scan by pen test team and CMS security team, and did not find any issue. We went through 508 compliant, VPAT 2.4. We did provide a test plan. We developed a test plan working closely with our team to develop the test plan. We scored 75. 1 failed, 3 and we are in a process to improve this score to be compliant for 508 based on a VPAT 2.4. We do have a release schedule for those finding to be compliant for 508, and we also provide exemption for Sparx EA, the feature-rich client, to be exempt from compliance, since this is the visualization team, and our 508 compliance team agreed to exempt Sparx EA from their testing. I'm on top of my minutes. Thank you for your time. I transfer it to Don, our API developer team.
Thank you. As mentioned, my name's Don Bowman. I'm the Senior API Developer on the Cedar project. I'd like to start by giving an overview of our API management suite that you can see here on the screen. Our API infrastructure is depicted here in between the two firewalls, the two logical firewalls that you see there on the diagram. The main tools here are the API gateway, the ESB or Enterprise Service Bus, and the API portal. So starting with the API portal, this is where outside developers can come in to see what APIs we published and made available to the outside world. Through the portal, they can learn about the APIs, they can see the input, output signatures, read descriptions that we've posted about them, try to give as much description on what the API does, how it's called, how it's used, etc. And they can gather all this information there via the API portal. So it's more of a way of disseminating information about the APIs that we have. Next then is the API gateway. This is one of the main parts of the infrastructure along with the runtime that you can see it connects to there. The API gateway is the entry point for all the incoming API calls. The gateway handles multiple duties. Some of the major ones, it does the authentication, authorization of the incoming API calls. It applies and enforces security policies. It also does monitoring, logging, analytics, and there's additional things you can do such as throttling, denial of service, monitoring, things of that nature. So we've got a lot of capabilities there on the API gateway. Kind of you can think of it as a gatekeeper for all incoming calls. Then next we have the ESB or the Enterprise Service Bus. This consists of both the API runtime and the integration platform. So the API runtime, that's where our REST API code is installed, loaded, and run. So that's providing that functionality there. The integration platform is more of your traditional Enterprise Service Bus functionality. This part of it has built-in capabilities for taking in data, and you can use pretty much any method you can think of, REST or SOAP API calls, file pulling, FTP, SMTP, etc. Just about any way you can get data from some other source, the integration platform can take it in. It has mapping tools to assist any sort of data transformations, database connectivity. So if we need to augment the data that's coming in, we need to pull in some other data from some other sources, put it together before we get it into the database. And then it has numerous other tools and libraries and so forth that really aid in rapid API development. So that's one of the big reasons and focuses there of that box, the ESB, is it really, besides the flexibility, it allows for very rapid API development. Outside of the firewalls, you'll see, like on the left-hand side, the developers. Already spoke about where they would come into the API portal and get information about the APIs we have available. Then under that, we have all the system API calls from other internal applications that want data, that want to access data that we have within the Sparx EA system. So as you can see there, like I mentioned earlier, all those calls will come into our API gateway to be authenticated and so forth before they get proxied into the runtime and eventually down to the Sparx EA system. And then the system census users over on the bottom left, they come into our website that we built for the system census, and that's where we do the yearly inventory, if you will, of all the systems, software, and so forth for the different groups within CMS. So they'll connect to that website, and that website will do all its communications to Sparx using the REST APIs that we've built and exposed via the API gateway. And then over on the right-hand side, just some examples. You saw that in one of the earlier slides of other data feeds that we're getting from external systems, whether it be Technopedia or some of our other internal CMS systems. So, next slide. All right, so on this slide, I want to discuss the approach we used for the communications between our API runtime system and the Sparx EA system, including how that was shaped by some of the main challenges we faced. So within our environment, the API developers, we aren't regular users of the Sparx EA system, nor do we deal really with the database or the data model extensively. That part of it's the realm of the architects and the DBAs. In addition to that, the Sparx API is very powerful, but it's a little more complicated than a generic REST API, and it requires some knowledge of the Sparx EA system. So given that, the fact that the API developers are not really familiar with the Sparx EA system, we wanted to try to figure out a way to abstract some of that from the developers. So the solution we've come up with is a combination of the Sparx EA API, database stored procedures, and database views. Excuse me. So for creating and deleting of objects within the system, we've created wrapper APIs that developers can call that require only the specific data needed to create that object. The wrapper API then, in turn, will handle logging into the Sparx EA system, doing the token request, formatting that data into the proper formats and structures that the API call to Sparx is requiring, and then the actual execution and checking the response codes. So by doing that, once again, we're able to abstract a lot from the developers. All they need to know is, this is, I want to create object X, these are the data fields I need to pass in, and this wrapper service will take care of it for me. So then in the case of a new object, we then use stored procedures to update the elements for the new object. The DBAs have created stored procs for the different types of objects that we create, and by doing this, we found there's a couple advantages. First, the stored procedures can have a good descriptive naming convention that's easy for the developer to relate to, i.e. the names relate to what type of object the stored procedure is updating. So that, once again, just abstracts that part of it from the developer. They don't need to know anything about the object, just that I need to update the elements on this one. I can find a procedure, stored procedure that has the name related to that. And then also with the stored procedures, using the signatures, it tells the developer exactly what type of data is needed to be passed in and what format that data needs to be in. Then next, for the querying of the data, so obviously a lot of the APIs are pulling data, either for our system census or external applications that want to get data out, either real time. Most of it is real time, but it could be batch if needed. But there we're using database views for each object. So like with the stored procedures, the DBAs were able to create views with an intuitive naming convention. So if you want to get information about a certain object, there'll be a view that has that object's name in it. So that makes it much easier for a developer, once again, to locate it. They don't need to pull in the database administrators, the architects, or anything to figure out, okay, where is the data stored for this? Boom, it's all right there in the view, and they can easily find it, locate it, and pull it. So for our situation, we found that the combination of these three seem to work really well. The one thing is, it really allows each group to focus on their core competency. The API developers are able to quickly develop without the need of learning the system. They don't have to get an in-depth knowledge of the data model. Once again, that's left to the DBAs and the architects. And the architects and the DBAs then are able to control how the data is being accessed and manipulated, because they're providing all that via the stored procedures and the views. Excuse me. Another alternative, another good thing about this is that we then don't have to train the API developers on the system and give them that knowledge. So this allows us, say, when we get into the system sense season and there's a lot of work, updates, and so forth to the APIs, we may have a need to pull in for a short period additional API developers. Well, they won't know anything about the system or the data models, things of that nature. So by doing this, they can come up to speed and be productive much quicker, as opposed to spending weeks or possibly months having to learn all of that information. So found this to be very efficient and very productive. So at this point, I think this is the path we'll be sticking with. So that's everything on my side.
Great. Thanks, Don. This is David Rice. I'm gonna pick up from here with a live demo. There's one little slide left for me, which just is this kind of the entry point that people see when they go into the Cedar environment. I'm going to focus on two things. Sparx, just kind of give you an idea of, okay, you've from everything we've heard so far, what does it look like in the Sparx database, and then give you some ideas, some flavors of the kinds of dashboards that have been created in Collaborate. So just to begin with Sparx, give you an idea of some of the breadth of information. I mean, you've heard Mike, you've heard Don, and Sharam and Crystal talk about this. But this kind of starts to make it real a little bit, is to see some of the different kinds of data that end up here and kind of where they came from. Haven't really spoken a great deal about the logical data model, but that is captured there, and it's I don't even know the count of tables, but quite a few that express things like the beneficiary and consumer information, health insurance program data structures and such, healthcare payments, quality and services, and provider and resource information. So that it gives us an idea of the kinds of data elements that we would have, the data structures that we would have in use by the systems. You've also heard about Cedar itself. You've seen this diagram before. Just to give you a quick look, that I think the expression is eating your own dog food. We do use Sparx to design how we're going to use Sparx, the Sparx platform, and that structure is captured as part of the overall repository as well. Then there are a number of project artifacts. These actually started life, many of these started life in a competing tool, which nobody's mentioned the name of, so I won't either. But there's a lot of BPMN, business process models that are built in here for various uses. Mike talked about this and understanding the business processes. This is a wide-reaching program. And there are no shortage of business processes to document, to understand, and loop into the overall architecture. And then finally, there's the enterprise architecture labeled piece, which is really where the tools such as the API come into play that Don was just talking about, system census application that everyone's talked about. The use of the API to populate this information, the use of the model flow tool from Sparx Services North America to initially populate much of this from other sources, And we find that we have things from the list of the systems that come from the system census and all of its myriad of traces and attributes. And of course, those of you who know Sparx, which I imagine most everybody on here does, is familiar with these windows for traceability and seeing the properties and whatnot. I will say I'm the fellow that bills the MDG for all of this. There is a very, very large set of attributes collected for the systems, and for other things, organizations and the like. And I saw a previous comment by Nizam about RefGood and RefGoods. We use those. We use connectors. We use pretty much everything you can think of in the available to you in the MDG tool set, as well as model-based add-ins to facilitate the collection of the information for systems primarily, but also the system interfaces in such a way that they faithfully represent the data as is captured in the system census tool. So in some cases it may require, and there's a few attributes that'll require the use of the model-based add-in to give the user the ability to capture data in the same vein. So that's an idea that some of the breadth like I say, you see organizations, you've got reference models, people, programs, investments, and then any of these packages may well have packages underneath them with large amounts of data, all of which centers around connecting either to the system inventory or to other. Well, it's an enterprise architecture, so it obviously highly connected model here. So that's kind of where all this data that everybody's talked about ended up in the repository, the Sparx tool. You're actually seeing a live version of the production database as I'm showing you what you see here. I'll switch real quickly then to the Prolaborate, and this gets into, Mike talked about the working with the stakeholders, working with those in the organization that have a need to understand information that's available to them, to kind of get a sense of the architecture and their use of it. And so these dashboards, and you saw there were quite a few on that first page, I just clicked on one of them, came about, the reports here, the content of the dashboards came about as a consequence of basically the questions that the stakeholders had that they would like to be able to address for their particular component. So I picked just the first component that was up there, and then this would get into the systems for that component and their relationship to certain elements within the architecture reference model. So we have the systems as they've come from the system census information and other sources, and how they associate themselves to a given reference model. And then, of course, based on user and some of the things you've already seen with Prolaborate, if you click on this, you get the detail over here. Similarly, you've got, it'd be nice to see what are the top systems for this component by user, and what are the number of users. What are the system costs? The top 10 in this case was the request. Things like the software products that may be ending supports. Now we switch to the notion of software products for this component used by systems that this component owns. And then you have other, the bubble chart here and Prolaborate for the system cost and by user count, and then some other products here for charge for end of support dates and other tools and techniques for kind of managing the system inventory for a given component. And you can see that there's quite a few different components here in this UI. Also interesting was the asset management dashboard. So here we've actually made use of some relatively new capability in collaborate with cards. I believe Nizam was showing that in a previous session, just to kind of give some nice summaries. What are the current number of active systems? How many contracts do we have active? What are the active software products? How many are expiring within 6 months? Some decent counts to kind of give folks some idea of kind of where they stand. Then a number of other charts and graphs here that might be useful for like where the data centers, how many of those do you have, top 25% of contract vendors, and then quite a few other subordinate dashboards as well that we can get to from here. So if we say, well, we want to see our software products by the vendors, and we can click on that and get into that. And this one's got a lot of stuff, but see some different charts for that one. And then let me go back to that one. So I think I wanted to hit this one here. Software product by service type to get an idea of that. And then there's of course the sub reports that you can get off of any of these pies that I'm sure many have seen. So you say, well, how many? I've got 462 application architecture and design products. What are they? And I can get the list of those and go through there. So the Collaborate dashboards, there's some already developed. There's many more in the works, and that's where the design sprints come in to get through that. And I am keeping an eye on my time. I'm going to save time for questions. So I'll end the presentation, my part of it there, and turn the floor back over to Mike for the retrospective.
Thanks, David. And yeah, there's a lot more work that we're doing on that front, but we do have to use our time between Sparx tool, and we talked about the system census. That takes a lot of our time too, and that's probably a whole nother presentation, so I won't get into that. But just kind of wrap up the journey that we've been on for the past several months implementing this new tool. I just wanted to reflect on a couple of different things that we were able to accomplish. First, we reduced our annual cost by just over $1 million. That's in licensing costs and contractor support. ERP was able to support the tool set under our existing contract. And those are annual savings. So it wasn't just a one-time occurrence. So that we were pretty excited about that. And secondly, since ERP was able to negotiate with Sparx to use their platform to set up the pilot, it saved us about $105,000 to get those up and running, because we were going to have to stand up a separate platform outside of our current one to do the pilot. And another benefit what we saw was the reduction of the complexity of our data. We were able to use the Sparx EA and Collaborate single database. This was an important change from our previous environment. I mentioned this before, where we were challenged to continually keep our two databases in sync. So moving to a single database for our modeling and our dashboarding saves us time and adds reliability to the data we present. The other thing we set out to do with this implementation is to use as much of the out-of-the-box configuration and standards as possible, eliminating customizations fitting in within the out-of-the-box configuration. The other things that we learned is that we always want to confirm the vendor self-assessment results. Crystal touched on this. Having a vendor self-assessment was a helpful tool when we were reviewing several EA vendors, but we also had to verify that what they were saying was actually current functionality and not planned, and not something that they could do with heavy customizations. We found that most vendors will tell you that they can do anything you ask, but it does come at a cost, and usually that cost is customization and extra work during and after upgrades. The other thing we talked about was the API gateway. This is one of the components that we added in order to actually make our previous system work properly. Without the gateway, the modeling and the reporting databases that we used before wouldn't keep in sync, and it was problematic. However, because, and we didn't touch on this a lot during the presentation, but the way we designed the EA tool, and in order to continue to have support of our CIO, we negotiated that we were the back-end database for his governance intake system, which he was very fond of. So we made sure that we were the database serving that system. And in order to maintain that connection, we needed to have APIs that we developed and to keep that system in sync with us. So that piece of the puzzle we want to maintain, and we found it gave us greater flexibility in integrating new data sets as well. And those are to both to feed our EA system, but also to feed that intake system that we use. I know there's some questions that were asked in Slack. So I don't know, Crystal, if you were able to look at any of those, if you wanted to add any clarification.
I can ask them here if you are okay to
yeah,
answer.
that's fine.
And you can continue the discussion later on in the Slack as well. But I guess there were a few questions. Crystal has already provided a response, but one of the things, like from Martin Sharp, is like, could you describe the size and roles of the team who look after the EA repository content and number of users? I feel this is an often overlooked vital resource that must, in my view, be in place for success. And
sure.
Mike, you want to answer that?
Well, I'll answer part of it, and I'll answer it in probably not super direct, because we do have something called the system census. That's our annual system census that we take. That is a requirement of the Klinger-Cohen Act of 1996, and we sort of built our whole program around that requirement. Although they just want to calculate how many systems the organization has. We added a bunch of other questions, and we use that to populate our repository. So we do have some people like dedicated to that. That I would say that's outside of this. So on the federal side, we have, I would say, 3 people that are dedicated maybe full-time and part-time. And then Crystal, I don't know if you want to comment on that contract side.
Yeah, so on the contractor side, we have approximately 30 people on the program. We have people that are working on the system census, dedicated working on the system census, and then we have some resources working on the API. We have three people working on the API and integration. We have architects that are actually going in and modeling every day. We have 12 or 15 of them. We have senior level people that are doing more of the orchestration and QA and developing the strategy. So approximately overall, there's about 30 people on the team on the contractor side. And some of those are the modelers that are assigned to model. So they're not supporting the tool per se. Right.
They're actually the ones doing the work to get the data in that we need to do the analysis.
I think that was really helpful, and it's a combination of these. And this question comes from Martin, whom I know manages a very large, like an EA practice in another large organization as well. So these insights will be really helpful. Thanks for sharing. There are quite a few other questions as well. Maybe we have some, like another 5 minutes. Are you okay if I ask a few more?
Yep. Mm-hmm.
Mm-hmm. Okay, so this is from David. When you speak to out-of-box versus customizations, are you referring to your EA tool set or a CMS business application development?
I could speak to that specifically. When we were doing the tool assessment, we needed to know from the vendors of the tool capabilities that they have. Would they require, was it an out-of-the-box capability? Was it a configuration requirement to meet that specific requirement? Or would the tool have to be customized to meet that requirement? And so one of the things that we did as part of our tool assessment was to actually provide the definition of what a customization is and what a configuration is, because we wanted to make sure everybody was on the same page, that everyone knew what a customization was, because that was always going to be considered as part of the tool assessment. So with respect to that, that's what we were using it for, was the tool assessment, not necessarily the CMS systems. Does that answer your question?
Absolutely. I think that's great. And there is another question from Rich. If you need objects broken out with specific object names, I think it's a little technical. You can answer it in Slack as well, but I'll just read it out. So if you need objects broken out with specific object names, why do the objects not have object names within the database? It sounds like that is a clear requirement. Objects need to have names so that they can be found in the data tier in the database. I think it's a tool-specific validation.
Yeah, that's a David question.
I'll look at the Slack question too and see if that makes more, if I can get more from
Sure.
it. But most things do have labels, have names of some sort. But I mean, one of the things you got to be careful of is name is key on anything. So most of the data, especially coming from an external source, has IDs. As you can imagine, with the system census and its data set and other data sets that have come into this single repository. We have to have mechanisms other than just a human readable label to identify things, and that's in place.
Yep, thanks, David. I think now there is one question which I would really like to have it answered while we are still in the session, which is, were there any lessons learned from this whole transformation initiative that can be applied to other government agencies facing similar challenges?
Mike, can you speak to that? Because from a government perspective, I think that would be really helpful.
I mean, from our perspective, I know it looked like someone asked about change management and those type of things, but be willing to make the move. If you're digging a hole and you want to get out, you have to stop digging, and that's what we ended up doing. And also, I mean, we partnered with a really great team. So I don't know if everyone has that same experience, but we had, just some great engineers from an API perspective, architects that were able to help us through this process, and pulling it from their network of people, and then teaming with. I mean, honestly, the Sparx team has helped us and quite a bit, and it wasn't like other vendors we used. It was like a quick pro quo, like we'll help, but then you need to pay for everything along the way, and it's very difficult in the government to do that because budgets are tight and things are set. So when we came into problems, it was just having the right partners made this all possible.
Thank you so much.